So I'm going to talk about core data today, and it's not going to be the intro to core data. It's more of the issues I've run across and how I've solved them, mostly in terms of memory and performance. So core data is very efficient. If you compare it to the same app that doesn't use core data for its persistence layer, generally the core data app is going to be more performant. The most popular way to persist your data using core data is SQLite. SQLite itself can handle billions of rows, records, tables, columns, and be very performant. It's not uncommon for an app to have 10,000 objects in core data and still be performant. There's no issue with that. But like a lot of the frameworks that we get to deal with in Cocoa, it does have some rough edges. The learning curve could be better. And if you misuse it or abuse it, you usually can see performance problems really quick. So the slides and the code will be at highperformancecoredata.com it'll be the first thing I do after this. So don't worry about if you see something go by real fast, it'll be there, and code as well. So I work at Chai One. It's a digital agency in Houston. Get to work on some cool apps with some cool people. Oil and gas is kind of headquartered in Houston, so there's no shortage of work. We're always looking to hire great people, so if you're interested, come talk to me sometime this weekend. I also created Buoy Explorer. It's a marine conditions app for water sports enthusiasts like surfers, kayakers, fishermen, boaters, anyone who cares about water, swell, or wind at a specific break or beach or location. And I use core data in this app, and I use core data poorly in this app. So I was upset with the performance, the issues, and so that kind of motivated me to learn the proper ways to work with core data. And so today we're going to talk about tools, how to do proper fetches, predicates, searching, importing data, concurrency models, app startup time, a bunch of little things that add up together to make your persistence layer performant. So this is the basic single manage object context stack that Apple will give you if you check the box in the Xcode template. Just a manage object context that talks with a persistent store coordinator that has a model or a schema for your database, which finally goes to a persistent store layer. And that's typically a SQLite file, but it could be in memory, it could be XML. And so when we talk about performance and core data, it's really a balance between memory and speed. You have this continuum. You can maximize speed at the cost of memory. You can reduce memory generally at the cost of speed. And so objects can exist in two places, on disk or in memory. On disk, it's going to be less memory, but it's slower. If it's in memory, it's going to be faster, but it's taking more memory. And so something with like Mavericks on the desktop or laptop is going to be have much more memory to work with, so it's going to be a lot faster. You can hold stuff in memory for longer and more of it. But something like iOS on a mobile device, you have much less memory, typically 1 gig of RAM, so you can't store as much stuff in memory. And so throughout this talk, you're going to see where I'm making choices. In this situation, I need more memory. In this situation, I need less memory to save on the memory and reduce the speed. So there's always this balance. You can't have both. You're going to have to pick somewhere on this continuum, and it's just going to depend on your app. So I built this app called UFO Sightings. So for the last 3 decades or so, people have been collecting sightings of UFOs all throughout the world. And so this is just a table list with a detailed view, and it has a description, a photo, sighted, reported, where, the location, and there's 60,000 UFO sightings in this database, in this core data stat, and it's still performant. And so I'm going to show you how you can have so many objects and still be performant. And it really starts with tools is the first step. From app to app, the data models are going to change. So I can't stand up here and give you this is the solution, use it, because it's going to be what I'm doing in UFO sightings is completely different than what you're going to do in something else. So unfortunately, there isn't this is always the right answer. But I can give you options that'll help you find the right answer. And one of those is tools. Tools don't have to be complicated. It can be a simple macro. You can easily measure how long an operation or method takes with just a simple tick-tock macro, just using NSDate, timer interval since now. Very simple. It doesn't have to be complicated. You could use it just like this. Most people know about the launch argument SQL debug, and so the verbosity of that output you can change with a 1, 2, or 3, and this is going to give you a bunch of stuff here, including your select statements as well as elapsed times. So that macro I just showed you, you could also do something. Just look at the elapsed time with the launch argument there, and see how long your SQL statements are taking. This, of course, assumes you're using SQLite as the persistent store. But there's a bunch of other launch arguments you can use. The threading debug is nice. So Core Data has very specific rules about multi-threading, and if you violate those rules, you can have an assertion thrown. Migration, if you want to see what's going on under the hood, enable migration debug. So there's several other launch arguments that you can use. Sometimes you actually need to look at the raw SQL database, the actual data on disk. Your Mac comes with a free tool called SQLite 3. And you can do stuff like querying the schema. So simple, just find the file on disk, the SQL file, the SQLite file. You can do select all from the master, and here's my main entity, UFO sighting entity. So you can kind of start to introspect your data model. And then you can do cool things like count how many unique UFO sighting shapes there are. So how many cigar disc shape, or how many orbs did the person use, and you can count them and group them. So if you're familiar with SQL, it's still there under the hood. You can still go and look at your data like this. There's also free tools out there. Pony Debugger is a popular one. It does way more than just core data stuff, but it does have a core data browser in it. So this allows you to see your entities and attributes and relationships. You just, at launch, you pass it a manage object context. And there's some more powerful tools like SQLite Professional is one of my favorites. And what's cool about this is you can import and export JSON or CSV, and you can kind of build a seed file using this tool if you want. And it provides a nice little Mac interface, table-based. And you can do your normal select statements right in that tool. There's also Core Data specific tools. This is Core Data Editor by Thermal Core. It's a GUI for managing your core data stack. What's cool about it, though, is that it's aware of Apple's naming conventions. So it's going to remove that Z prefix off of everything. And of course, the biggie is instruments. That's probably the most important tool. You could probably forget about everything else I said if you just concentrate on instruments. There's a built-in core data template. That's a great place to start. It's going to give you fetch counts, how long they took, cache misses or faulting, save times. But there's also file activity and the timer profiler. Those are all good tools to use in instruments. So the first step when trying to work with core data, I think, is the tooling. And it doesn't have to be complicated. It could be macros, but it probably should be instruments. And before you make any changes to your core data stack, you should measure, measure, measure. Always measure your stuff before you actually make these changes, because otherwise you're just guessing. So let's talk about fetching. In general, don't fetch more than you need. It's easier said than done, but that will go a long way in helping you stay performant. So in this UFO sightings app, I'm going to just launch it and scroll a little bit, and then I'll go ahead and look at the gauges, which is new in Xcode 5. So you don't even have to launch instruments to see your memory usage. And I'm at 125 megabytes. It only says 0.76%, but that's because I'm running on the Mac. On an iOS device, that's a lot of memory. But I don't really know why or what's happening there. So gauges gives you that quick look on what's going on. The next step would probably be to launch instruments and use the core data template. And then, so again, I'm just going to launch the app, scroll a little bit. And then if we go ahead and stop, the first thing you're going to notice is that the fetches there are large blocks, large columns. That's generally not a good idea. That's generally indicating a blocking of some kind. And so if you notice the app took a while to start up or launch, actually before you saw the UI, it was in that area. And so if we look down here at the fetch count and fetch duration, you can see the 60,000 UFO sighting objects, but you can also see it's taking over a second to do that initial launch. And no one likes a slow app that takes forever to launch. So let's see if we can fix that. The easiest way to do it, it's surprising how often I see this in code, is that people just forget to set a batch size. This one line right here will do a whole lot for you. Typically a good idea is just to double the amount of things that you're showing on screen. So if I'm showing 10 rows, 20 would be a good number. And so if we set that, if we do a simple set that batch size to 20, we're going to see instantly with one line of code a massive improvement. So I launched the app. It already launched much quicker. I don't know if you can notice that, but if you look at the gauges now, it's only 20 megabytes instead of 120 megabytes. So I already saved 100 megabytes of memory. And again, we can look at it in more detail if we launch instruments. This is still the last trace, but if we wait for it to launch, there's still a line there. It's still thicker than I'd like, but it's much thinner than before. So remember, I'm doing 60,000 objects, which maybe isn't a real-world situation, but it's a lot easier to talk about taking a launch time in minutes down to less minutes, and then it is talking in milliseconds. So I specifically picked a large data set just so that we can see the numbers change drastically. And so this time what's different is that the fetch duration is now less than a half a second. Fetch count is still 60,000, but this is just a count now. It's not actually fetching the managed objects into memory. But you can see 20, 20, 20, 20. That's that batch size. As I scrolled, it's bringing those 20 into memory and then removing the last 20. So say you have a screen like this, a summary screen. So these are I showed you that SQL statement earlier. These are the unique shapes and how many times they occurred. So a disk, an orb, a light. So if you want to generate a summary screen, there's several ways you could do that. One way is you could fetch all of your managed objects and iterate over all of those managed objects and count those unique shapes. This is not the way to do this. It's the slowest approach. You're fetching everything into memory, and then you got to iterate over everything. It's going to be slow. What you could do is change your fetch request result type to NS dictionary result type, and that'll allow you to get back just the properties you care about. So in this example, we can just get the shapes of every object back as an NS dictionary instead of returning all the managed objects and then enumerating over all of them. But an even better approach would to let SQL do that calculation for us. So you can use an NS expression. And if you've worked with predicates before, what you're really doing is combining multiple NS expressions. And so in this fetch request, instead of using all managed objects, or instead of setting it to NS results dictionary type, I'm going to pass it an expression where it's saying I want to do a count. So that same SQL statement I did earlier manually, I can put in this expression. And now it's going to give me a listing of all the unique shapes as well as how many times they occurred in all of my objects without bringing all that into memory. I'm just going to get a really small NS dictionary. And so NS expression is extremely powerful. It should be a talk or multiple talks into itself, but it does a lot of stuff: average, sum, min, max, as well as some more complicated stuff like standard deviation, ceiling. So if you have a data summary screen that has some kind of statistics or math involved in it, look at NS expression. Another thing you can do to speed up your fetch request is to prefetch any required relationships you have. So for example, in the UFO sightings app, there's a photo associated with each UFO sighting. But maybe I have that in a separate entity, and I need to look at it later on. But it's going to happen, and I know it's going to happen. So a good idea would be to tell the fetch request that eventually I want that. So it'll prefetch it for you. So with fetching, just don't fetch more than you need. Set a batch size. Don't forget that one line. And prefetch anything that is required. So let's talk about predicates. When you're doing these fetches, you generally want to limit what you're fetching, and a predicate is the way to do that. But when working with predicates, you should do light comparisons first. So let's say I want to look at all UFO sightings that are a sphere shape and a duration of less than 30 seconds. So this means someone saw a sphere in the sky for less than 30 seconds. This is one way you could write the predicate, but a better way would be to put the numerical comparison first. Computers are good with numbers, not so much with strings. Seems obvious, but when you're in the trenches coding, it's an easy thing to forget. And so in general, you should be cautious with strings. So in terms of cost, begins with and ends with are going to be the quickest. Matches is going to have to fire up a regular expression engine, and so it's going to take the most time. So if you can, use begins with and ends with. Also, if you do case or diacritic insensitivity, that's going to cost you even more. So if you can, don't use CD. So with predicates, it's better to do your light numerical comparisons first. Begins with, ends with is way better than contains or matches. And just don't use case and diacritic insensitivity. And we'll talk about how you can avoid using that here shortly. So searching is an action where a person is actively searching. They're going to want to take an action immediately on those results. So that's not really a good time to have slow performance in your app. If someone's searching and they have to wait, it's not a good experience, at least frustration. So one thing you can do is canonicalize your string properties that you're searching against. And that's just a way of saying normalize the string properties. So for example, if you've got a description of the UFO sighting that someone wrote, and they might be in multiple languages, might have multiple diacritics, might be all caps, strip that away, make it as normalized as possible. You can do that with a custom setter. So when you set the description on your manage object, you could update a canonicalized or normalized version of that description and keep that along as well. There's multiple ways to do that. CF string normalize, CF string fold are some good functions to look at. So if that doesn't increase your performance enough, one thing you can do is use tokens or normalized tokens. So on that description attribute, instead of having one massive description, you can break it up into tokens. So separate all the words. And you can separate it quite easily. You can just do a component separated by characters and sets. So take this massive paragraph of the description, normalize it, separate by all the spaces, and save that off as a separate entity. And now you can use begins with to search those tokens. And it's going to be much faster than searching a paragraph of unnormalized text on your main entity. But if that still isn't good enough, one thing you can do is use a separate stack. You can have two completely different persistent store coordinators, persistent stores, and manage object contexts. One just for searching tokens, one for everything else. The thing with this is, though, that you can't pass objects between them. You can't pass object IDs. You can do stuff with URI representation, but I mean, it's difficult to debug, but if that's what you need, then this is one option. And if that still isn't good enough, you could hash the tokens in memory. And it doesn't have to be the whole token. You could just take the first 3 letters of every single normalized token and keep that in memory. It's not going to be, even if you have 60,000 objects, if it's just the first 3 letters of every single word, that's not going to be too much. So for searching, normalize your text properties, use tokens. A separate persistent stack is not out of the question, and a hash if you have to. So for the data model, there's a couple things you can do. You can not over-normalize. So normalization is the process of reducing the amount of duplication across your database. But for iOS in particular, it's generally better to let your UI drive your model. So start with your UI or your wireframe and let that kind of drive your model. And don't be afraid of duplication. Another thing you can do is use external storage. So if you have a large blob, maybe a photo of the UFO sighting, if you check this box, core data is going to make the choice for you. It's going to decide if it should store it, if it's more efficient to store it in the actual database or if it's better to store it on disk. But all you have to do is check the box. So for example, I have a photo attribute on this UFO sighting entity. Instead of keeping it on the entity, I could keep it as a separate entity and have a relationship to it. And so if I have a list of UFO sightings that I don't need that photo, there's no point in bringing that into memory every time just to show a list of these sightings. And so in this example app, the UFO sightings app, I do have a photo shown though for each row. So maybe that's not the best option. And when you tap on the row, you get the full photo and all of its glory detail. So one thing you could do is create a thumbnail of that full photo. And so keep the thumbnail on the primary entity, but put the full-size photo on a separate entity. And this generally goes with the philosophy of less data takes less time to fetch. So we've reduced the amount of data on that primary object, the UFO sighting, and replaced it with a thumbnail. So for the data model, don't over-normalize. You can put large blobs as separate entities, and sometimes that'll help. And if possible, if it's a photo, put a thumbnail on the entity, because that's going to take less time to fetch. So app launch. No one likes a slow app launch. There's a whole bunch of stuff you can do to speed up your app launch, but as it relates to core data, one of the usually the first things you want to do is set up your persistent stack. The problem with that is if you're doing a migration, it can take a while. If your store is just large, if you have 60,000 objects, it will take a while to come up. It used to be in iOS 6 and later, iCloud would block while it was linking and stuff. With iOS 7, I believe that now returns instantly, and it does the linking to iCloud in the background. But there's a way you can get around that. You can just set up your persistent stack in a async dispatch queue, and what this will do is create the stack, and then you can, via maybe notification center or some other way, notify all your view controllers that, hey, the stack has been initialized. Now you can actually go fetch your manage objects. So there's another problem called what I call lots of things problem, and that's just because I haven't found a better name yet. But a lot of people get down on core data because they can't say they're an RSS reader and they've got a million objects and they want to mark them all as red. Core data doesn't provide you a way to do that easily. You have to iterate over every single object and mark a status as red. But there are some situations where it's not the end of the world. Some stuff you can save to a point in the app where it doesn't matter that you have to iterate over all these objects. For example, an application did enter background, you could create a background task and do that long-running work. You get an undetermined amount of time, but maybe 5 minutes or something. But you can take advantage of when the app enters in the background and do some of those long-running operations. So importing data is also a primary pain point for core data. Most apps need data to be useful. If that data is static or never changes, you should probably ship it with the app instead of making a network request on first launch. But if it's dynamic or user-generated, you probably need to import it in some method or fashion. So again, going back to the UFO sightings map, I'm going to launch instruments and perform an import operation. So it's the same app we've been seeing, but now I'm going to tap on import in the top left, and it's going to import, refresh, and re-import all those 60,000 UFO sightings. And right now I'm trying to scroll on the table, and it's blocking the UI. It's hard to see, but it should be scrolling. And so now if we look at the time profiler and allocations, and I speed it up, this import of 60,000 objects on a Retina MacBook Pro Core i7 is taking over 5 minutes. And so that's obviously unacceptable. So we can solve that blocking issue quite easily. We can use a private queue instead of the main queue. The reason that UI was blocking is because we were doing all this work in the primary main manage object context on the main queue. And we can create a private queue with this init with currency type, NS private queue concurrency type. This was introduced in iOS 5 and OS 10.7. It's iOS 5, I think it was kind of buggy. I think iOS 6 it stabilized. And iOS 7 is definitely, you should use it. So you just create a private queue concurrency type. You give it the same persistent store coordinator. So I'm getting the persistent store coordinator from the main manage object context. In iOS, you don't really have to set the undo manager to nil, but I like to be explicit. And so if we just do that one thing, and we move it to a private queue, and we run the same app again, launch instruments, and we start to scroll and then we hit import, and then we start to scroll, I can still scroll. The UI is not blocking. This didn't solve the problem of it taking a long time, but the UI is still responsive, which is already a massive improvement for the user. And so it's still going to take that 5-minute time frame. And so to solve that long 5-minute import, we can look at the typical find or create import algorithm. So usually you got JSON, you serialize it, you have NS dictionaries, and then you need to determine if it's a brand new object or it's something you already have. So you fetch your manage object from the store. If it doesn't exist, you create a new one, and then you update or you set the attributes on the manage object. And really what's taking the most time in these steps is this find existing manage object or create existing and create the manage object. So that find or create process is what takes the most time. And usually it's implemented something like this, where you pass in a unique identifier, you do a fetch request against that unique identifier, the predicate, and you pull it out. And so issue is I'm fetching one thing. And so for 60,000 objects, I got to go fetch 60,000 things separately. And I have to check and see if it's there or not. So there's a much better way to do this process, this import process. So if we have our JSON or our new data on the left here, and our old NS manage objects are persistent objects on the right and old data, there's a much better algorithm. You could iterate through both of them and check and see if the object exists. So for example, on old data, I've got them all in memory. I check, does one exist? Yes, it does. It's an update. Then I increment both enumerators, and then I see, does 2 exist in the old data? Do I already have 2? No. Well, then do an insert. And then it's inserted. I don't increment the old data counter. I do increment the new data counter. And then again, I check again. Is it there? No. Well, then it's an insert. And then I increment both counters again. And then I see 4 exists in both. It's an update. So the difference here is that I pulled in all of my old data objects, and I'm iterating through both of them. I don't have to do these one off at a time. And so you could implement this with something like this. You could use NS enumerators on the JSON array, as well as on the fetch array returned by the fetch request. And then while you still have a UFO NS dictionary, you can loop through them, check if the manage object exists. If it doesn't exist, you can create the new object or set the attributes on it or update the attributes. And then if it's an update or not, if it's an update, you increment both pointers. If it's not, if it's a brand new object, you just insert it and you only increment the NS dictionary enumerator. And so if we switch from that naive or inefficient find or create algorithm to the new and improved one that we just described, we should see a performance improvement. So that's the last trace. But if we launch, we scroll, the app's still working, we tap on import. The app is still scrolling, it's not blocking the UI, which is good. And then if we look at what Instruments is doing, it took 1 minute and 20 seconds instead of 5 minutes and 20 seconds. So we shaved off, I guess, 80% of that time. But one thing to note is that allocations, the memory there, is not pretty. That's not good. So we've gotten the speed 80% improved, which is good. The UI is not blocking, but the memory is still an issue. So there's 2 issues with that allocation. One is that I'm loading a 150 megabyte JSON file into memory. And because this isn't a talk about streaming files from disk efficiently, we're not going to do anything about that 150 megabyte JSON that's sitting in memory. But we can improve the fetch request, and we can improve it by batching. And so we talked about this new efficient, or this better way to do a find or create. And I pulled in all the manage objects, and that's why the memory was so high. But we can batch that and still use that efficient find and create algorithm. And so before we just had one update loop. Now I've created another loop, so we've got two loops, and one's a batching loop. And so this is how you could do that. You could make a range of your new data based on your batch size, and then you can do a predicate with format with the in keyword. The in keyword, there's key, and so that's only going to fetch the manage objects from the persistence store that are in that JSON batch. And so now you've limited each fetch size, so you've reduced your memory footprint. But another thing you can do to improve importing is just ship a pre-populated SQLite file in your app bundle. If the data doesn't change often or ever, just ship the file with it. You don't need to hit the network on first app launch. Obviously, this doesn't work if you have dynamic data or it's unique to the user or it changes often, but it's easy. You just put that SQLite, the seed file, in your app bundle, and then at launch, you just move that SQLite or copy that SQLite file over into the documents directory and call the add persistent store with type method on that new SQLite file. Another thing you could do is actually download a pre-populated SQLite file. So theoretically, you could have a Mac server running that is generating core data formatted SQLite files and then serving those up over an API. And you could just download that SQLite file and replace your persistent store out right from under the app. But it's probably not the best way to do that. You could probably, some kind of cron job where you are generating that SQLite file occasionally and then statically serving it is probably a better option. But the thing is that there's ways to handle large data and still import and still be performant. So for importing data, it's best to work on private queues, use an efficient find and create algorithm, work in batches to keep your memory low, and if you can get by, just use a pre-populated SQLite file. So we've been touching on memory a little bit here, but it's mostly been about speed. So for memory, there's a couple things you can do, but really you should just learn about refresh object and reset. Refresh object with merge changes no is going to turn that object back into a fault. So that's one way to reduce your memory usage. If you're done with the object and you don't think you're going to need it for a while, you can just refresh the object. Or if you're done with the whole context, you can just throw it all away with a reset. Those are quick ways to reduce your memory usage. And so the fun thing is concurrency models, or at least I enjoy the various ones that have kind of sprung up recently. So a time's going to come when you're going to need to do a background task. Like that import operation I was showing, we needed to do that in the background on a private queue to make it performant and not block the UI. Fortunately or unfortunately, there's tons of different concurrency models, and there's not a right or wrong one. We started off with the basic one that Apple gives us, and you should start with this and stick with this if it's not a problem. There's no reason to get complicated. You should stay with this until you think you have a problem or you've measured an actual problem with instruments. So stick with the basic. The problem with this is, and we showed that with the import operations, that the UI is going to be blocked. Your main queue is blocked when you're doing an import operation. And you can't read and write at the same time. The persistent store coordinator serializes all objects no matter what. So you're not going to be able to do multiple things at the same time. So you could go to a model like this, where you share a persistent store coordinator and you have a private queue and a main queue. With iOS 5 and OS 10.7, we got confinement types, so you can say this is a main queue confinement type, this is a private queue confinement type. And you can use the private queue for your large tasks or your background importing, and then all your UI work you want to perform on the main queue. And when working with these, you got to use the perform block or perform block and wait API calls. But still, the persistent store coordinator serializes all operations. So if you're writing with this private queue, you're not going to be able to read from disk on this main queue. The persistent store coordinator is going to lock you. And so one way you can improve the performance here is you can use contexted save notifications and merge any changes that the private queue has right into the main queue. Notifications, those notifications are fairly light. It's only going to be what changed. But a better option is not to do that, but to just wait until that background task, that import operation, has gone to completion, and then just refresh, just throw away your main queue or restart over on your table view. There's no need. I always see it in apps, but when the import operation is coming, I'm seeing my table rows move around and import. There's no need to do that. You could just wait until the operation is complete and then refresh the whole table. Another model that's kind of got popular recently is this idea of having a context that doesn't have a persistent store coordinator but has another context as its persistent store coordinator, kind of. Again, this is introduced in iOS 5 and 10.7. And so you can tell the main queue that it has a parent context, and that parent context could be a private queue. And so you could do your UI work on the main queue as usual, and then you could do persisting to disk, that saving action, on this private queue. But you still have that same problem of when you're doing work on that main queue, you're going to be blocking the UI. And then also, you have the problem that you have all objects are serialized through the persistent store coordinator. So it's going to block there as well. So we can add another level of complexity to this and throw in another manage object context into this. And so now we've got a private queue on top of a main queue on top of a private queue, finally to the persistent store coordinator, and then to the persistent store. And so again, we would do our background or import operations on this private queue, and then we could do our UI work on this middle queue, this main queue, and then finally persistent to disk with the private queue. But again, you're going to lock on the persistent store coordinator because everything is serialized through that. And so another thing I don't really like about this technique is that the code gets messy. So blocks are great, I really enjoy them, but blocks nested 3 levels deep kind of is hard to read and gets confusing. So if you wanted to save all the way from that top manage object context all the way to disk, you would have to do 3 nested level blocks on that temporary or private queue block, on the main queue, and then on the background writer private queue. You would have to save all 3. And so here I'm using that perform block API. And so I took out all the messy code, but it's still nested 3 level blocks. It's not very pretty to look at, in my opinion. So I kind of showed you 2 models right now. One's not right, one's not wrong. It depends on your app. So this model here, where you have these 3 nested contexts, might make sense if you're like a Scratchpad or a Drafts app, where everything you do in this context matters to this context. So you could create a draft or a private context up here, a Scratchpad, do all your work, and then you can either just throw it all away or save it. And when you save it, all that data is important to this context. So it makes sense to do this stack if you have a Scratchpad type of app. But if you're not a Scratchpad or something like that, or if you need to import large amounts of data, then in my opinion, this is a better model. So you can do that import work on the private queue and keep the main queue free so your UI doesn't block. Both are, this has kind of been around for a while. It's probably the more popular option, and this is, I've seen a lot recently, and I think it's been applied in the wrong cases a lot recently, but they're both valid solutions for your problem. But there's more models. These aren't the only ones. You can even do stuff like this. You can have 2 separate persistent store coordinators, 1 persistent store file, and then you can have your main queue and then your private queue. So when the private queue is doing that background work and this persistent store coordinator is blocking because it's serializing all its requests, it won't be blocking this persistent store coordinator or this main queue, this context. The persistent store, a file lock is much quicker than a persistent store coordinator lock. So the fact that you're still locking here will have some impact on this, but it's not going to be as large of an impact as this type of lock. But with iOS 7, this issue goes away because we get write-ahead logging for our SQLite stores. And what that means is that you get multiple concurrent reads and a single concurrent write on one persistent store on one SQLite file. So now while this guy is writing, you can have multiple reads coming off of it, and it's not gonna appear to block. And again, the same things we talked about earlier with posting a save notification and merging those changes in, that still applies. You can still do that with this setup. But again, maybe you shouldn't. Maybe you should just refetch the whole data set after the save has completed. And so if we change our import operation on that app that we've kind of demoed a couple times now to this multiple persistent store coordinator stack, let's see what happens. So I tap on import. The UI is not blocking. I go to instruments. Again, I haven't solved the JSON memory file issue, but I've reduced it another 30 seconds from about 1:30 down to 60 by just doing this other option. That's because while I was scrolling, I was no longer blocking the persistent store file because I had multiple persistent store coordinators. But if you do this stack, it's not as easy to debug. There's some issues. You can't pass objects between them. They have separate persistent store coordinators, so you can't move those objects between them. You can't pass object IDs, which is often what you use in multi-threading. But you can use a URI representation, and you can merge changes from the notification. So I think it's still useful. But really, I just threw a bunch of models at you, and a lot of people just want tell me which one to use most of the time. And in my opinion, it's this one. I think this is gives you the most flexibility, and it's the easiest to debug, and it's probably the most popular out there. So more people are familiar with this type of setup. So for concurrency models, you generally want to use the simplest model that'll fit your needs. There's no reason to get complex. The more complex you get, the more difficult it's going to deal with when stuff breaks. And you should also only update the main context after a large import has completed. So there's no need to update it if you're batching a find-or-create algorithm every 20 items that you import. And so with core data, it generally makes people want to bang their head or have bad thoughts. But I don't think it has to be. I think in this whole talk, there's at least one thing in here that maybe makes it less painful. And so in general, some of the key points that we covered were, use the tools, measure, 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 measure. There's no point in changing anything if you don't know what you're changing or how you're going to change it or what the impact is going to be. I like that simple macro. It doesn't have to be complicated. Don't load more than you need in general. But load just enough, of course. There's no reason to keep hitting the disk. Don't use case and diacritic insensitivity. Your data model, be smart about it. Take that large photo, put it in a separate entity, maybe store a thumbnail in your primary entity. That thumbnail is going to be smaller than a large photo. Import on private queue. Make sure you're doing it in batches to keep your memory footprint low. And then pick the simplest concurrency model that's going to fit your needs. So again, the code and the slides are going to be up here in about 15 minutes maybe.